Good morning, everyone. Let me share my screen. Are you guys able to see my screen?
Yes, sir.
Yes, sir.
Yeah. Yeah, thank you. Now let's quickly see what we have learned yesterday. So I'll be sharing by tomorrow night. I'll be sharing the notes, like updated notes with the discussion details that we have done. Let's quickly see. So yesterday we were looking at about a schedule thread pool. Can someone tell me what is a schedule thread pool and how it is different from fixed or cached?
So we are scheduling for particular time. So in the future, it will start execution.
How can I, like, what method I need to call? Which method does that work?
Scheduled method.
Schedule method.
Yeah. So in order to call the schedule thread pool in the executed service, executors, we have a new schedule thread pool.
Schedule thread.
Yeah. Using the schedule thread pool, you can introduce a delay to a thread. The thread will start after some time, whatever the time that you are mentioning. So the schedule thread pool is returning a scheduled executor service, not the executor service. In the schedule executor service, there is a method called schedule method, or schedule at regular interval, or schedule with a delay. Some methods are there. This schedule method is too responsible for independent path of execution, and it will create the thread with the time that we have mentioned here in the time of seconds or minutes, whatever it is, right? And whenever we are working with the schedule thread pool, the object, if the thread is returning an object, how to accept that object? What we should use?
Schedule future.
Yeah. Instead of a normal feature, we have to use a schedule feature. Schedule feature internally extends from a future interface.
Future interface.
Yeah. And we also discussed about future. So what happened, like whenever we are working with threads, how can I get the value that is written by a thread?
Callable interface.
Callable interface is returning the value. Once it is written, I want to get the value. How can I get it?
Future interface.
Yeah. In the future interface, we have a method called get method. Correct. Future interface dot get method. It will give you the object that is written by the callable. And what happens if the thread is not completed a execution, but I'm calling the get method? What will happen?
It will throw exception.
No.
Get method, how is the last?
The first is done. We have to check. After that, we have to whenever that thread is completed, that execution, then we will get that result.
Yeah.
It will update that one.
Yeah, I understand that. But for example, if I'm writing, see here, I'm getting from the list, I'm getting a schedule feature, and I'm calling the get method. So, so what I'm doing is, from the main thread, I started a thread. Okay, that thread has not completed; it is still executing. But from the main thread, I am going into this line and then calling the get method. Then what happens to the main thread?
So main
It will wait.
right here.
Yeah. So for example, so that means the get method will create a blocking operation. So if the value is, if the thread is already completed, then the get method will return the value. Now, for example, if you are trying to get the value while the thread execution is in progress, then what happens? The get method will make the current thread, whichever the thread that called on a get method, the thread will go into a waiting mode or stepping mode or blocking mode, etc. Right? So whenever we are using the get method, we should be so conscious, right? What else we have discussed yesterday? I think this is the only, right? Yeah. Now let us look at, so the thread pools we have completed, and so we have completed the synchronization, etc. Now, what are the advantages? So now whenever you are writing a synchronized keyword, so can I say we can write the synchronized keyword, synchronized block? What's a synchronized method? So whenever I'm trying to show you the class lock, object lock. What I have done, can I say that I have made the method as a synchronized?
Yes.
Yeah. Now, for example, let us take display. And today I'm going to tell you how to create a thread using Java 8. I'm not teaching the Java 8, but you guys know that in the Java 8, whenever we are writing a lambda is nothing but we can replace the anonymous inner class with lambda. Do you guys aware of that?
Yes.
Yeah. So we are going to look at that, how to create a Java. So here, so we earlier, whenever I'm writing a method, so I'm making the method as synchronized using the synchronized, adding the synchronized keyword to a method. Now, I don't want to, so in this line, in this method, so I don't want to synchronize all the lines of code. There may be the problem with the synchronization is whichever the threads, which are like that means, for example, I'm passing the object here, right? So if I pass the same object to multiple threads, what will happen? One thread will start executing this method, and on the same object, any other threads cannot execute any other method, correct?
Yes.
Because it will acquire the log. So whenever we are, if this is a scenario, in real life, there are some situations where we don't need to do the thread safe or lock mechanism for all the lines of code which is written in a method. For example, if I write some 10 system.out.println, so do I need to worry about locking the code for synchronized system.out.println?
No.
No. So system.out.println can execute. I wanted to keep high. Or for example, I want to do the cleanup like object creation, etc. Only some part of the code I want to synchronize, then synchronized method is not useful. Synchronized method will make entire method as a synchronized. But what we can do is by using the synchronized block, particular part of the code we can synchronize. Look at here. So this is how we can write. Now, for example, if I write I1, I2, I3, I4. Okay. Now we will see the difference between a synchronized block and synchronized method. Now only 3 and 4 I will keep it in the synchronized block. In the first example, in the display method first, what will happen, guys? So when one thread is working on this object, it will acquire the lock. Can any other thread on the same object will be able to execute display method?
No.
No. But in the second scenario, is your method synchronized?
No.
No. Then can I say, even if I create multiple threads, all the threads can come to line number 13 and 14 till
Yes.
line number 14? Yes. But if one thread enters the line number 15, can other threads will go into a wait mode, correct? Now let us see that. Now let me write main method. So generally, how do we write a thread? Extends the thread class and then override the run method, correct?
Run
Yeah.
method, yes.
But can I write an anonymous inner class? So I don't see. Yeah. So from the run method, I want to call this display method or display one method. Okay. Now, so generally what you guys are aware as of now is write extends keyword and then implement a runnable interface or extend a thread class and then create a object of the class, child class, and then call the start method. This is how we can create a thread. Am I right?
Yes, sir.
Everyone agrees with me?
Yes.
Yes, Karthik.
Yes.
Okay. Now carefully observe that I am writing an anonymous inner class. Or first I am writing an inner class. I don't want to
One
do.
more thing, Karthik, in the synchronized block, you are passing that object, right? Somewhere I saw it is object name dot class. Is it required to do it? Or object is fine?
Here it depends on what I'm passing. I can pass the object. If I want to acquire the object lock, I will pass the object lock. If I want to acquire the class lock, I will pass the class reference or
okay.
class name.
Okay, got it.
It is same as object lock and class lock only.
Okay. I mean, if it is static class, we usually pass class,
Yeah.
class, right? Okay.
Yeah. So thread, how to create a thread object case? Class constructor, correct?
Yes.
Yeah. So thread T equal to new thread. Okay. Now, and see here, so when the minimum thing is if you can extend the thread class and sorry, you can implement a runnable interface. Whenever I'm implementing a runnable interface, how to create a thread object?
Calling the
You have
Passing
to pass the runnable
runnable into
class.
the thread
We have to
class.
implement the runnable
Okay.
interface to the class, and then we have to pass the
Class
class.
into the
Yeah. First, I will have a class which implements runnable, and this class object I will create the class C equal to new class, and this class object I will pass it. I have to pass it in this one, correct?
Correct.
Now I don't want, see, if I do class and implement this one, I will do that, but I don't want to do that also. Directly here I want to do. What I will do, new runnable. What is the interface I will implement? Runnable. So runnable is an interface in Java. We cannot do, but if you say new runnable, look at here, anonymous inner type. That means you are creating an anonymous inner class. So see, look at here. New runnable means, see, I created a class. I mean, like this will be like a class, but that class does not have any name. And internally, I am overriding the run method. Now, what I want to do in the run method, I want to call the display method, correct? Let me pass the call the display. Let me create an object. Let's start display, and I will pass S, correct? Yeah.
Yes.
So now, can I say, am I creating any class and implementing a runnable interface and all? No. So this is, can I say this is an anonymous inner class? Now.
Yes.
And I have created with this now, thread object is created, correct?
Start.
I need to call the start method.
Yes.
T.start. Some people, what they will write here itself, they will call the start method. So that is also correct. So it is a simplification. Instead of writing in 2 lines, and they are calling the start method on top of it. Now let us quickly debug this and see. Let me keep a debugger. Whenever you say T.start, see, it has created a independent path of execution and it is acquired the lock, correct? Any other thread can execute any other method, synchronized method on the same object?
No.
No, because it has acquired the
Lock.
Okay. Now, if is it a object lock or class lock? It's a object lock, because you can see if it is a class lock, this symbol would have been different, correct? Yeah. Now, now instead of calling display, now let's call display 1. Now let me show you first. It will not acquire the lock for the first time itself. Okay. Now look at here. Do you see any lock symbol?
No.
No.
Here also no. But let us see when it enters, when it is entering line number 16. See, do you see the lock now? That means till line number 14,
Yes.
can I say any number of threads can execute the display 1? Yes. But whenever one thread is executing line number 16, all other threads has to wait till here only, correct?
Yes.
So using the synchronized block, what can happen is, so if you don't want to synchronize, the entire method, you want to synchronize particular part of code. For example, generally where we want, whenever you are doing the database connection, you cannot do just like that, correct? You have to wait each thread, like one thread complete the database connection, then other. because if you completely call the database connection, you will end up creating multiple database connections, which is a not good idea. Because when you create a database connection, you have to make sure that it is closed or not, etc. Right? It's a costly operation. So what you can do, the database connection, everything you can put on a synchronized block. You will write non-synchronized code in the above or below. So that is how we use it in a general project. Okay. Now
And
let
the
me
synchronized block also we should see it's already database created. We should not be creating. Like,
yes. Yeah. So now there is one more thing. So in Java 8, so this is a, did I write any Java 8 code? No, it's a normal anonymous inner class. Now, what is the lambda? Lambda expression is nothing but it is a replacement of using one of the advantage of lambda expression is we can replace the anonymous inner class. Now, how can I do that anonymous inner class? So this run method is a functional method. Functional interface. Runnable is a functional interface. For functional interface, I can write a lambda expression. Now, let me show you guys how can I write a lambda expression for this. Thread T equal to new thread. Okay. Now, so what, see, lambda expression, whenever you're writing a lambda expression, I'm writing a lambda expression for abstract method present in a runnable abstract method. Now, what is the abstract method present in a runnable?
Run
This
method.
one, run method. Now, can I say this is a signature? Yes. Now, copy this and now let me write it. Now, lambda corresponds to an interface. Now, what is the interface I want to write a lambda? Runnable interface. So generally, whenever you want to say string variable, string s equal to ABC, correct? What is the meaning of this one?
Storing the ABC inside S1.
Yeah, ABC is a S1 is a variable, which is a type of a string, and it is holding the value as ABC.
ABC.
Correct? Am I right? Now, similarly, whenever you want to write a lambda in Java, so in future, maybe after 1 week or 2 weeks, I'm going to start the what you call Java 8, 9, 11. And before that, I will keep a free demo session on functional interface, lambda expressions, etc. You can attend that and you will get more clarity. But I'm just trying to tell you in using Java 8, how can you create a thread object? Okay. Now, so this is a normal variable declaration. Similarly, in Java 8, there is something called lambda. What is a lambda? Lambda corresponds to an interface and specifically abstract method. Now, that means we can write a lambda for a functional interface. So now there are many functional interfaces I can write. How do I know particular lambda I'm writing for a particular event? How do I know this S1 is what type of a variable? You are writing a data type, correct? Now, if without writing, can I know what is a S1? No, correct?
No.
We should mention the data type. With the data type, you can say, hey, Karthik, this is a string variable. Now, similarly, I want to write a lambda. That lambda variable name I am keeping L2, L1. Now, how do I know for which interface I am writing a lambda? You need to write that interface. So in Java, we have a data type set. Similarly, for interface, whenever you are using have a interface, for interface, you will write a lambda expression. So I'm right now. What compiler will understand? L1 is a lambda variable, and this is nothing but this person Karthik is writing a lambda expression for runnable interface. Okay, done. Now, generally, whenever you are implementing a runnable interface, what do you guys do? Whenever you are,
we need to write a class and we need to implement it.
yeah, implement runnable interface. After that, what do you do?
Run method.
We need
We
to
can override.
implement
You
the
need-
method.
Override run method.
Yeah, you will override the run method and you will write what logic to be executed, correct? Whether system.out.println or calling some other method, correct? Now, in this scenario, can I say this is my logic of a run method? No.
Yes.
Now, what we can do is, so generally, in order to override a method that is present in an interface, the general practice that you have to do is create a class, implement an interface, and then override the method. Am I right?
Yes.
I repeat my statements. Till now in Java, if whenever you want to use an interface, so what you can do is create a class, implement an interface, and override the abstract method, right? So that means by doing all this, what are you doing? You are providing a implementation for abstract method. So with a Lambda, you don't need to do all of that. Like you don't need to create a class, you don't need to override the method, etc. So directly runnable L1 equal to what is your purpose after creating a class and implementing? See here,
Override.
overriding, correct? Directly, I am overriding here. So here, the compiler will understand that this L1 is a Lambda expression, and this person is writing this Lambda expression for an interface called runnable. Now, how does the Java will know that which in the runnable there may be multiple methods? No. If you look at here, runnable, it is an interface which has one abstract method only. Lambda expression you can write for an interface which has only one abstract method. Hence, that is made as a function interface. Okay, now done. Now, whenever you are writing, so can I say by what is this runnable? It's a interface name. So compiler will already know for which interface you are writing a Lambda expression. Now, then what it will go there. And specifically, you can write a Lambda expression for an interface which has only one abstract method. Then, what does abstract? What is the name of a method? How many arguments it is taking? What is the return type? So, what it will do? Compiler will look at the abstract method present in this interface and it will derive. So, you don't need to write anything specifically. Done. So, currently, if am I passing any arguments here? No. How does the JVM will understand? JVM will understand is it will see L1. Okay, that's fine. What is this runnable? It's an interface. That means I have created a variable for a reference variable for interface. That means this is nothing but a Lambda. So the compiler will go to this runnable interface and it will check. Yes, in this runnable interface, what is the abstract method called? It's a run method. Now, so method is run. Return type is void. Does it take any argument? No. Okay.
No.
By looking at the signature of this abstract method present in this interface, it will understand. So you don't need to specify. Okay, done. Now, what is C? Whenever you are overriding the run method, open bracket and close bracket. What does it mean? By writing the open bracket and close bracket, you are providing the behavior. What it has to do, right? So this is also nothing but this open bracket and close bracket. This will provide the behavior. So this is the parameters. Between the parameters and behavior, you need to add one arrow mark. That's it. Now this is a Lambda expression. Now this is a Lambda expression. Okay, now, and whenever you say like if, can I say if I want to execute one statement and else I want to execute one statement. So then do I need to write a curly bracket?
No.
See, like when you will go for a curly bracket like this?
Multiple statements.
More than 2 statements.
More than one line. Correct?
One line.
If I have a single line, do I need a curly bracket?
No. Optional.
Similarly, can I say that here how many lines of code I am executing in the, see, whenever I am overriding the run method, how many lines of code I am writing?
One line.
So this is a blank space. It is not considered, correct? Now,
Yes.
so can I say here I am executing only one line. Do I need this curly bracket?
No.
Simple. I can simplify further, right? If I am
Yes.
writing more than one line, I have to keep. If I don't, then can I say this one? Remove?
Yes, we can.
Okay. Now, can I say that this is a Lambda expression? Yes. Now, whenever you're creating an object, this Lambda runnable, so this object you need to pass it here. That is, so this is a Lambda, like Java thread creation, thread object creation using a Lambda expression. Or, see, can I say what is the meaning? See here, if I am calling the ABC, some show method, and can I say if I want show, there is a method called show, and if I am passing S1, what does it mean? Show method is taking a string argument and you are passing here, correct? Now, can I also do the same thing like this instead of declaring a variable like this? Directly, can I pass the data like this?
Yes. Yes.
Now, can I say what am I doing here? I am, for example, first I am creating a Lambda variable, correct? And then I'm passing that here, correct? Now,
Yes.
can't I write that Lambda expression directly? Yes. correct?
Yes.
Yeah, right.
So this itself is lambda expression. Like this is Java object creation, like thread object creation using a Java 8. Okay. Now what is the meaning? What is happening here? So can I say that this, whatever you have written, this is nothing but a your run method implementation?
Yes.
Okay. Now run method does not take any arguments. So here no arguments. And after the, see, before the arrow mark, these are the parameters. After the arrow mark, whatever the implementation you want to do. Now in the run method, what is the implementation I want to do? S.display1 S. So here also I'm doing the same thing, correct? So that means from the run method, you are calling the this display1 method. So this is how we can create thread object using Java 8 lambda expression. Hope you understand. And then I need to call the start method. See, this thread object is there. Now you need to call the start method, correct?
Yes.
Yeah, done. So this is a thread object creation using Java 8. Now if, so the, let's say, because how to create a lambda and all, that is a different topic. You don't need to do for these threads, but after my course is completed, somewhere you might see this code and you might be thinking that I did not explain. No, this is completely different. Whenever you have an anonymous in a class, if you know how to represent an anonymous in a class using a lambda, then directly you can come here. Okay, so
in
this,
this case, can we have two different functional interfaces have same method? Display
yeah,
one and display.
yes.
So in that case, how does this pick the?
You want to
constructor?
create one more thread which calls the display method?
No, in this case, we have display one method is in runnable. Assume we have
Run method. From run method, we are
run
calling
method.
yeah.
So which is implementing runnable there. Now assume that one more run method is there.
One more run method means you want to create one more thread.
I was trying to understand.
You want to call one more thread.
He's asking in different interface if we have run method. He's asking that. Yes.
No, in different interface we have a run method in which we are calling again display one. Which one it will pick up?
So which one? See, now so different interface means in Java, for example, the thread, what the thread constructor will accept?
Runnable.
Okay, runnable object only. You are saying that, for example, you have created another interface called test. Okay. Now in the test also you are keeping a same runnable abstract method,
exactly.
correct?
Right.
Okay.
Right, exactly.
Now, and does your thread constructor will take that test object? No, right?
No, no.
If you pass this one, what it will understand? It will understand that you are providing an implementation for runnable interface only.
So
correct?
I assume that I have two classes. One is test one, other is test two. Test one is implementing runnable. Test two is also implementing runnable.
So you don't need to write, whenever you're writing a lambda, you don't need to write create a class, implements abstract method, nothing. Did I do anywhere? You look at here. In this example, do I have a run method?
No.
So that is what you don't, so with a lambda expression, what happens is, whenever you have a interface, what is the practice that you have followed? Create a class, implement the interface, override the abstract method, correct?
Okay, got it. Yeah.
You don't need to do all of those here. Did I do anywhere?
Yeah.
You are directly creating a thread object.
Got
And
it.
so this is a thread object creation. And then whenever you're calling start method, now the question is, sir, run method is not there, how it will go? Now, see, this is a run method implementation, correct? Now, if you look at here, this is the run method, which does not take any argument. And this arrow mark, what does the arrow mark will tell you? What is the implementation? Whatever the code that is present after the arrow mark, that is the implementation. That means from the run method, you want to call a single line of statement, that is s.display1. Okay. Now the question, so I want to call multiple methods. Then what I will do? I can keep a bracket, open curly bracket and close curly bracket, correct? And then I can write and semicolon, right? Now, if I want to write one more system.out.println, or I want to call s.display, can I do? Yes.
Yeah.
And then semicolon, right? So this is a lambda. So don't worry about a lambda expression. Maybe
one question, so Karthik, in case if we have, let's say thread method was actually here overloaded. let's say it is accepting runnable as well as callable. Then
How
if you
how
without
thread will
writing that
accept?
interface.
Wait, first, let's your question clarify first. Thread constructor cannot accept runnable and callable first, correct?
No, assume that thread is
No,
accepting
not
both
assume. It is
runnable
not like
object and
assume.
also
You
callable.
come with an code and then I will explain. It is not just like that, okay?
No, instead of thread, let's say my custom class is a method is accepting runnable interface and callable interface. If you don't
Yes, you can write. You can write 2 lambdas, right?
So which one it will pick up runnable? If I don't write
depends on-
runnable or callable, which one it will pick up this one?
Just like that example, you cannot explain. Okay. So just practice and then come back with the questions. That would be.
Yes, Karthik, because I have a doubt
Okay.
I'm asking.
Okay, fine.
See,
Yeah, let me show.
If I practice already, I know that, right? Then nothing to ask here.
Yeah, that is what I'm asking. See, when you have a doubt, first practice, and still it is not clear, you can come back and ask. Okay.
See, I got this doubt when you are explaining. That's why I'm asking, Karthik. How
Okay,
can
fine.
I practice
Okay, fine.
when you are explaining?
Okay, fine. Let's not debate. I'm explaining. Just wait.
So if this is the case, I can't ask any doubt then.
See, am I not explaining your doubts in the regular
Yes.
class? Every day you will be asking.
No,
Are
you're
you-
asking me, you practice.
So there is
and then
there
ask
should
me.
be
So
a
I
there
can't
should be.
practice when I get it out.
Shankar, don't make it as a debate. Wait. So there are other students in the class also. They should also be getting an opportunity to ask
Correct.
questions, right?
Karthik, other students also. That doesn't mean that I cannot ask doubt, right?
Okay, fine. Okay, leave it. Fine. Let me explain. Okay. So you are asking like runnable interface is there, callable interface is there. Okay, whenever you are
we
creating.
have only one it is accepting only one. It is overridden method actually. This is third example is having a overridden parameter. One is runnable and other same is overridden with callable.
Okay. Based on the whatever you pass, it will accept. Whenever you're writing a lambda does not take about what object you are passing. So whenever you are passing here, whenever you're writing a lambda, callable interface also has one abstract method. You can write a lambda expression for this, then it will understand. By looking at the signature of your method, it will understand.
So
and here your
if both the methods has the same call. In this one you have a run right method, runnable. Like that in callable also assume we have run.
But still your object parameters are different, right? Here, by looking at this, see, look at here, it is an object, it's a callable and it's a runnable. In Java, this happens, right?
Right.
Yeah, then it has a differentiation to do, right?
No, but we are in the lambda, we are calling lambda using the inside method, right? Run method only, right?
So you see, whenever you are writing a lambda, did I mention, see, it is becoming a lambda session. So whenever you are writing a lambda, can I say that you are writing interface name also? Right?
Here,
So,
I mean, next line, next method.
See, in the next line, I did not write because what the
in
thread constructor is, wait. What thread constructor is taking? Here, what thread constructor is taking?
Oh, okay. Based on the constructor, what it is taking. Okay, got it. Now I got it. Thanks.
Okay. Fine. So this is how the way how to create a thread object using a Java 8 lambda expression, guys. So this should not be a new thing to you. So that's the reason I have explained. If you have more questions, then I request you to please try how to create a lambda, how to work with a lambda expression. Once you understand that, you can easily implement the lambdas here. Okay. Now let us come back to the lock mechanism. Now, in the synchronized, we have a synchronized block, right? Now, if multiple, see here, whenever multiple threads are executing on the same object, can I say one thread will execute and remaining threads will go on to the wait mode?
Yes.
Now, whenever the other threads are going on to a wait mode, so do we know which thread, see first one thread has acquired the lock. Let me take an example. Okay. So T1 thread is working on Karthik account, T1 thread, and it is executing some method called deposit. Okay. Can I say it will acquire, it's a synchronized method. Can I say this T1 thread has acquired the lock on Karthik object?
Yes.
Yes.
Now T2 thread is working on Karthik account, and it is trying to call withdraw. Will it work?
No.
Can I
It
say
is work, sir,
immediately
because it's not
it is a
synchronized.
synchronized method? Yeah, good. So T2 thread, can I say T2 will go into wait mode?
Yes.
Okay. Okay. Now T3 is also working on Karthik account, and it is trying to call some balancing query. And this is also synchronized method. Now, can I say that T3 also will go into wait mode?
Yes.
Yes.
Okay. Now, when T1 has completed the execution, like the deposit method, can you guys tell me which thread will come back to the execution?
T2 has to come.
No.
Sometimes T3 also can come, right? It is not in our
Yes.
hands. Am I right? Okay.
Yes.
Now, but if I want, out of this execution, I want which thread has acquired the waiting for longer time. That has, out of this is the first one, this is the second one, this is the third one. Can I say T2 went into the waiting mode first and T3 went into a waiting mode second?
Yes.
So that means, can I say that T2 was waiting for so long than T3?
Yes.
Yes.
Now, if there should be a mechanism, whichever is the thread that is waiting for longer time has to given the
Priority.
access.
First
Yes.
chance.
If that is the case, can I do that in the synchronized keyword?
No, sir. It's inside a synchronized block we can keep.
Inside synchronized block also, can you say which thread can execute? Do you have even whether you write a synchronized block or synchronized code, at any point of time, whichever the thread is executing synchronized block or synchronized code, so it will acquire the lock and all other threads will go into a waiting mode. After that thread, whichever the thread is acquired the lock, once it is releasing, so any thread that is waiting will come back to the execution. But can I say that whichever the thread that is waiting for longer time should come back to the execution?
No, we can't.
No, we
No.
can't, right? Yeah. So so can I say that is one of the bad drawback, right? So that's where, so this is one just simple drawback, guys. So that's where what we can do, whenever you are writing a lock mechanism. So in the lock mechanism, what happens? There is a fair lock, there is a unfair lock. Using a fair lock, if you follow the fair lock, see, you can see in the current happened, T1 has acquired the lock. T2 was waiting for a long time, and then T3, and then T4. So that means whichever is waiting for a long time, that will be given the access first, and then next, and then next. So that is called fair lock. So in the unfair lock, whatever the synchronized code is executing, that will execute. Now in the unfair lock, what is the problem? Can someone tell me?
So maybe one thread will wait for so long.
Yes, that means you don't even know whether that will come back to the execution or not, correct?
Yes.
Waiting thread will be there in the waiting for so long also. And you do not know when that will execute, correct? Right?
Yeah.
Yes.
So that is a problem. In order to solve that problem, and see, whenever I am using a synchronized block, I want to achieve a lock in one method and release the lock in another method. Is that possible? See here what happens after completion of this display method, after completion of this line number, if it is a synchronized method, after completion of line number 10, the thread will release the lock. Am I right?
Yes.
Yes.
Okay. Now, if I take a synchronized block of code, after completion of line number 18, can I say the lock will be released?
Yes.
Now, my question is, I have an implementation in such a way that whenever the thread enters the display method, create a lock. Create the lock whenever the thread enters the display method. and release the lock after high 2 in display 1. Is that possible? Understand? Do you guys understand what I'm trying to tell you? I repeat again. So what is the display method? Is it synchronized display method?
Yes.
So whenever the display method is synchronized, so after completion of line number 11, then only the thread will release the lock, correct?
Yes.
Yeah. Now, if I write a synchronized block, after this block is completed, then only it will release the lock. Now, can I say synchronized block can be written inside a method only, correct?
Yes.
Yeah.
Now, for example, I am telling you one scenario. Acquire the lock in the display method, and from the display, go to display 1. Okay. And after in the display 1, release the lock after high 2. If I want to achieve this functionality, is this possible using a synchronized keyword?
Yes, we can.
How?
Inside
I want
the,
to, yeah.
inside the synchronous, why
Using
display method?
notify.
No. So whenever you say no, so if, for example, wait notify, what happens? It is telling one thread to other thread. But I'm talking about acquiring the lock itself, right? You're talking about after releasing the lock, right? So wait will release the lock. I'm talking about acquiring the lock. I want to acquire the lock in one method. See, using a synchronized keyword, your lock is there till the last line of a method or till the last line of a synchronized block. Am I right?
Yes.
Okay. But my scenario I am asking is, so there is a display method. When one thread starts executing this display method, I don't want to use synchronized. Okay. I want some mechanism. When one thread accesses this display method, it should acquire the lock. Okay. Now, what happens once it has acquired the lock? I don't want to release the lock in the same method. From this method, I want to go to another method. And in the another method, after completion of 2 lines, I want to release the lock. So this kind of requirement might come. But if this is coming, can that requirement be facilitated using a synchronized keyword? Do you guys understand the problem?
Yes, we are understand.
Yes.
Yeah. So we cannot do with the synchronized keyword because synchronized keyword can be used to a method or within the method, but not across the methods. Am I right?
Yes.
Yes.
Hope you understand there is that something. See, earlier there is another advantage like so other disadvantages. Whenever you are using a synchronized keyword, the thread which is waiting can go into a waiting mode for longer time because you do not have a mechanism saying that whichever is the thread that is waiting for longer time should come back to the execution. You do not have that mechanism, right? But that is one disadvantage. And another disadvantage is I want to acquire the lock in one method. From this method, I will call another lock and then release the lock. So in order to do this, generally people will think that, sir, why can't we start the synchronized block here and then release end the synchronized block here? But synchronized block, we can write within the method, not across the methods. Am I right? Now let's try writing it. So you might be thinking, why can't you write synchronized D and close this block after this? Is it possible? That means, can I say my synchronized block is going across the methods? Correct.
Yes.
This is not possible, right? What did I say? We can write a keyword to a synchronized to a method only, or we can write a synchronized block within a method only. Correct. But can I write a synchronized block across methods?
No.
No.
I hope you guys, everyone understood this problem.
Yes.
This is very important. So this is that means using a synchronized keyword, do I have the ability to lock them, acquire the lock in one method and release the lock in another method?
No.
So this is a disadvantage of another disadvantage of a synchronized keyword. So in order to overcome this, we go for a lock interface. Now in Java, now let me remove this code. Okay. In Java, in Java we have a lock interface. Now let me show you that. Let me write lock L. Now what is this lock? If you look at here, see in the java.util.concurrent, which is introduced in 1.5. So look at here. See, there is an interface called lock. Okay, in Java. So what does it mean do? See, by using the lock method, it will acquire the lock. So we will see all of those later. So lock method will acquire the lock. And there is another try lock. I will come to the try lock later. So there is one more method called unlock. Unlock method will release the lock. Now the question is, can I use, since it is a lock is an interface, can I use it directly? Can I use this method directly?
No, we cannot.
No.
So someone should have been provided a over implementation, correct? Yeah.
Yes.
Now let us look at here. See, it is present in the java.util.concurrent.logs package. Now, do you guys see another thing called read-write lock? It is another interface. It has a read lock method and write lock method. Okay. Now, so using a lock interface, you can, there is a method called lock. You can acquire the lock. And then there is a method called unlock. Using that, you can release the lock. I will come. So there is another interface also called read-write lock. It has a read lock and it has a write lock. When we have to go for this read-write lock, I will explain later. Now, if I want, currently as of now, I know that lock is an interface. If I want to use this, I need to have a class which is implementing interface and should have overridden this method, correct? Because if I create a class called test implements lock, do I know what is the logic to implement write the lock method?
Yes.
No, as a developer. So what I'm trying to say, the functionality of a lock method is to acquire the lock. But
Yes.
so if I directly use this interface in my class, I will create a class called test and I will implement a lock interface. And I have to override this abstract method. But do I know what is the logic I should write inside this whenever I override?
Yes, we have to.
But do we know?
Sir.
We do not know, correct?
We don't know.
So Java people have similarly, whenever you have a list interface has add method, delete method, remove method, etc. So, but why array list class is created?
To implement the add method.
Yeah, array list is implementing a list interface and providing the implementation for all the abstract methods. Am I right?
Yes.
So that because of that, you don't need to worry about why it is working and all. Similarly, in Java, under the lock mechanism, there is a class called reentrant lock. Okay. Now, if you look at here, what this lock is, what this class is doing. Say reentrant lock implements lock interface, correct? So that means now whenever I want to use it, can I use directly?
Re-enter lock we can use.
Lock L equal to new reentrant lock. Can I say like this? I can create an object. This is same as
Yes.
list L equal to new array list,
Array
correct?
list. Yes.
Right? Okay. Now I will come to later. There is another class called reentrant read-write lock. We will come to this. What is this lock later? So there is basically we need to learn under the lock mechanism what is reentrant lock, what is read-write lock. Okay. Now, so that means for lock interface, lock is an interface. Can I say reentrant lock is a class which is providing the implementation for all the methods in this interface?
Yes.
So that means in this class, they should have overridden the lock method, unlock method, some other methods.
Yes.
Yes, they have.
And in the lock method and on the unlock method, they should have provided the code on how to acquire the lock and how to release the lock, correct?
Yes,
Yes.
yes.
So as a developer, if I don't use this one, if I directly implement this interface, can I say that I do not know the implementation of those unlock and unlock methods and I will be worried, correct?
Yes.
So whenever you are using a lock
Yes.
interface, you have to create an object like this, lock L equal to new reentrant lock or lock L equal to new reentrant read-write lock, correct? So these are the two implementations of a, say, reentrant read write lock is also a class which is implementing read write lock. I'll come to the read write lock later, but I'm just trying to tell you the class behavior. Okay. Now, see, reentrant read write lock. Read lock, it is implementing a read lock. Read lock has an interface which has an abstract method called read lock and write lock. Okay. Now let us, now if I want to create an, so I have shown you the example with a synchronization. Now we have discussed about the drawbacks of a synchronized keyword, right? Now shall we discuss about the creating a class by implementing a lock interface? Yes, let us see. Create a class. Now what I will do, thread example, or see, lock example. Oh, it's already there, lock example 1. Okay, now in this lock example, now what I should do, I have to create first of all private lock L equal to new reentrant lock. Guys, it may take another 5 to 10 minutes. Will that be fine?
Yes, Karthik.
Yes, good.
Yeah. What about others?
Yes, Karthik.
Okay. Okay. So, okay, done. Okay. Done. Now, let me create a same display method. Let's copy the method from the here. Okay. You don't need to worry about a display. Okay. Now we will come to the method and other that one. So here what I will do, I want to acquire the lock inside a method, like similar to the synchronized block. Then what I will do, L.lock. Okay. Now, so now after line number 4, I want to release the lock. L.unlock. Done. Now, so what? So here I will through the main method, I will create multiple threads and I will pass the same object to a multiple threads so that I can say with how it is happening. Correct? Now let's write main method. In the main method, what I have to do, I have to create a thread. How to create a thread, guys? Thread t equal to new thread. And can I write a lambda expression? Yes. Now, whenever I'm writing a lambda expression corresponds to a abstract method present in a interface. Now, so you don't need to write a method name return type. And run method is not taking any argument, so I'm not putting anything. And then what is the implementation I want to use? Arrow mark. So in this one, I want to call the display method, right? Now let me call the display method. And what does the display method is taking? Okay, now let us take. Now let me take instead of that class object, this class object. Okay. Lock example. Now I want to pass this one, correct? Now how can I pass? I will create an object here. Yeah. Lock example d equal to new lock example. Okay, done. Now let us pass display. Now how this is the instance method. Now how can I call the instance method on top of an object, correct?
Sir,
D
can I
dot
pass
display.
this here instead of D?
This means yes, current object will be taken. Current, but I don't want to pass the current object. I want to pass this, right?
This is also current object only, sir. Constructed.
Yes, correct. So, but here, for example, after this line, if you create one more object, whenever you say this, that becomes another object, correct?
Yes.
You can pass this also, but whenever you are passing this, you should be careful, right? That is what I am trying to say. Okay.
Okay, sir.
Yeah. So now what can I say that I have? This is a thread object creation, and this is a implementation for a run method. What am I doing inside a run method? I'm calling the display. Now this is one thread. Now can I create another thread?
Yes, you can.
Yeah. So can I? So now how many? 4 threads I'm creating. Correct. Let me do. So can I say 4 threads are working on same object or different object?
Same object.
Same object.
Okay. Now, so here I have implemented using a thread class by lambda expression. If I have to implement the same threads with multiple, like normal way of extending a thread class or implementing a thread class, then how can I do?
Override the run method and call that display method inside the
So,
run.
but how can I pass the object to that run method? Because run method does not take an argument, right?
Take a constructor.
Yes. That means for 4 threads, you need to create 4 classes, correct? And implement a runnable interface or override extend the thread class. And then in the run method, you need an object. So how do you get that object? For those thread classes, you need to create a constructor. And in that constructor, you have to accept an object. That object has to be passed from the main method, right? Which we have seen in the multi-threading
Yes.
example or other places, right? Yeah. So if you are doing a normal way, that is the way. If you are doing it by creation lambda expression, you don't need to, because you are simplifying the code. You don't need to implement right and all. Okay. Now, can I call the start directly t.start? Now, can I also call the start here itself? Yes. Look at here. So, but it becomes confused. So that's the reason first I'm creating an object and then I'm calling the start method later. Okay. So now t.start, t1.start, t2.start, tt.start. Now, can I say all this will start executing the run method? Yes. So do you have a run method here? No. But where is the implementation for a run method is present? This one, correct?
Yes.
From the run method, what method you are calling? Display method, correct?
Display.
So it will go to the display method, correct? And inside a display method, what are you doing? You are acquiring the lock and releasing the lock. Now, say here, whether it's a synchronized keyword or lock interface, what am I doing here? I am creating multiple threads, and these multiple threads are working on same object. It can be a same method or different method, right? When one thread is accessing one synchronized method or one synchronized method on one object, it will acquire the lock. Can other threads will work on the same object by calling the another method or same method? No. So the same behavior should come here. Now let us look at debug as Java application. Now, whenever I debug, whenever I say t.start, can I say it is creating an independent path of execution?
Yes.
And it will go to run method and it has to start executing display method, correct?
Yes.
Yeah, now look at here. One thread will start. See, first thread has created and then it started executing this one. Okay. Now let us do all the threads. Okay. Now can I say all the threads started? Yes.
Yes.
Now can I say which thread I am executing? 3. Now when I say t3 dot, I'm going inside this. Okay. Now can I say that you don't see the lock symbol here because like the lock will acquire, but the lock symbol is not there because the implementation would be different. So now can I say T3 thread is acquired the lock on this object, D object?
Yes, we can say.
As per the concept. Okay.
Yes.
Now, as per the concept, what it is telling, when one thread is acquired the lock on one object, can other threads execute the same method or different method on the same object?
No.
No. Now, if I execute this one, if it is going inside this, it is executing. If it is not going, if it is going into a wait mode or stepping mode, can I say that it is waiting?
Yes.
Yes,
Yes.
we can.
Now let us do. See, I am doing F8, F6. So is it went into a stepping mode? That means it is waiting.
Waiting.
Okay.
Yes.
Now here, is it waiting? Yes, again it went to a stepping mode. Now let's go to thread 0. That means, can I say that lock is acquired by thread 3 on the D object? Thread 0, thread 1, thread 2 are also accessing on the same object. Hence, there is a object lock and these threads are waiting, correct?
Yes.
Now, whenever I complete this one, whenever I complete this line number 17, can I say the lock will be released?
Yes, it has to release.
Whenever it is releasing, out of these 3 threads, you can see stepping. One thread should come back to the execution, correct?
Yes.
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 Yeah, now let us see. See, okay, now let us complete this. See, before whenever I was in the last line, thread 2 started executing, correct? And see, thread 1 and thread 0 in the stepping mode only. Now let us look at here. What I will do, can I say if I complete the line number 17, I'm completing the, I'm releasing the lock, correct? Now, see, look at here. Still my code is in the same method. This thread 2 is executing display method only. But is it outside of an unlock method? So thread 1 started executing. Look at here, correct? That means, is it working similar to the synchronized keyword or not?
Yes.
Yes.
Okay. Now the problem, what is the problem in the synchronized keyword? The waiting thread, so which thread will come back to the execution, you do not know, correct?
Yes.
But if I make that work, like for example, I will do something, and then I will make first a T3 thread execute. Then T1 thread will go into a wait mode, then T2, then T0. Now after completion of T3, now let me write here. So I will start first, I will acquire the lock using T3. Then once there is a lock, if I try to call the same method with the T2, can I say it will go into wait mode?
Yeah, stepping mode. Yes.
Okay, which thread went into a wait mode first?
T2.
Okay, now later T0, I will try to debug. Then it will go into a wait mode. Second, which thread went into a wait mode? T0. Now I will do T1. Now I will do some changes to this code, the reentrant lock code. And whenever I release this lock, if this has to execute first, after completion of this, then, can I say that whatever the problem was there in the synchronized keyword, that means whichever the thread that is waiting for some time, based on the waiting time, the thread has to come back to the execution. If I am doing that, can I say that I am overcoming the drawback of a synchronized keyword?
Yes.
Okay, now let us see that. Okay, I hope you guys are understanding, right?
Yes.
Yeah. So now let us F8. Done. I have completed all. Now, in order to do that, see, currently in the reentrant lock, where is the class? Yeah. So this is a class. Can you say this class will also have a constructor? Yes. So this is currently what I'm doing. Can I say whenever I'm creating an object, can I say this constructor is invoked? Look at here. Can I say I'm calling the no argument constructor? Yes. Now, there is one more constructor also. Do you guys see? Yes. And what it is accepting? One Boolean value. So if you pass, that means what is the possible values for a Boolean? True and false. If you pass true, then that will be called as a fair lock. If you pass false, then that will be called as an unfair lock. So that means, can I say in the no argument constructor, what are they calling? Internally what object they are calling? Non-fair sync. If I pass false, can I say that will be going to the non-fair sync only? Yes. That means don't pass any argument or pass the false. Can I say it is same, the behavior? Yes. I repeat my question. So whenever from the lock example, am I passing any argument? No. Whenever I'm not passing anything, what is the object that is getting created in line number 294? Which class? Non-fair sync. We don't know what is this non-fair sync and all. We'll come back later. But this is something like an object creation, right? Done. Now, so instead of using this constructor, I will use this constructor. Can I use it? Yes. Now let us do that. If I use this constructor, I have to pass the value. Now, what are the values I will pass? False and true. Let me pass false. If I pass false, can I say this will be called now? Now, what is the value of fair? It is false. Whenever it is false, will this be executed or will this be executed?
Non-fair sync.
So whenever this is a ternary operator, in the ternary operator, whenever the condition is true, this code will be executed. Whenever the condition is false, then whatever the code that is there after the semicolon will be executed. So that means it will call non-fair sync. That means whenever I don't pass any argument, also non-fair sync. Whenever I pass false, also non-fair sync. Is it correct?
Yes, it
the
is.
same behavior, correct. Right? Yes. Now, when the behavior will change, whenever I pass true. Now, true. So whenever you don't pass anything or whenever you pass false, whatever the synchronized keyword behavior is there, right? That means the first one thread will go into a wait mode. And once that is released the lock, which thread will come back to the execution? We don't know. Any thread can come back. But if you pass a true to the whenever you're creating a reentrant lock object and you are passing a value as true, then the lock will be acquired or the waiting threads will be given as a priority. Whichever the wait thread that is waiting for longer time will be given the first priority than the other threads. Okay. Now let us look at now same code. Let me debug it. Now only change I have done is I passed it true. So as per example in the diagram, so which thread I want to execute first? T3, correct? Now let's start all the threads. T1, TET. Okay, sorry. Let's come back to the main method. See, thread 0 is line number 0 lock. This one also. None of the threads have acquired the lock as of now. See, all the threads have started. Okay. T is nothing but T0, guys. Now, T3 is started executing the code inside the lock. Can I say T3 has acquired the lock now?
Yes.
Now, after
Yes.
that, which thread I want to execute?
T2.
T2, correct? If I say T2, can I say the T2 will go into the wait mode now?
Yes.
That means first, I mean, like, can I say wait, T2 wait started now, correct?
Yes.
That means what is the time now? 7:09 something, correct? Okay. Now let's now we'll go. So now let's go to the T0 now. Let's go. Let's wait for T10 7:10. I just wanted to demonstrate with the time so that you will understand.
Karthik, we are unable to hear you.
I am not speaking anything. I'm just waiting for the time to become 7:10. So that I will call this thread. See, yeah,
Okay.
7:10. Now, if I say F6 here, can I say that T0 will go into the wait mode?
Yes.
Now, so which one? Say T0 went into wait mode at 7:10. Okay. Now let's wait for T 7:11, and then so when this T3 is completed, which is the thread that is waiting for longer time out of all these three?
T2.
So if the T2 is coming back to the execution, can I say that whatever the problem that is there in the synchronized keyword I have overcome?
Yes, we can
Yes.
say that.
Okay. Now let's wait for 1 more minute for 7:11.
Okay.
If I do not wait, do you guys will be able to see? There is a difference, but I cannot tell you, correct? Yeah, now 7:11. Now can I say T1? Now T1 thread into waiting mode, correct? Done. Now let's come back to the T3 and then complete the execution. Okay. Now whenever I complete line number 17, the lock will be released, and which, as per the concept, since I'm using a fair lock, which thread has to come back? I'm expecting T2. Done. See, T2
Yes.
started executing.
Yes. Sir.
Yes. Now let's complete T2. That means out of all the three threads, whichever the thread that is waiting for longer time is given the priority.
Yes, Karthik.
Okay. Now let's look at what is the other thread after this which is waiting for longer time?
T0.
T0. Correct. Now let us do F0, F5. So can I say T0 is coming back to the execution? Look at here. T1 is in stepping mode only. T0 is coming back to the execution. Yes or no? Guys.
Yes. Sir.
Yes, Karthik.
Yes.
Yeah. Now, if I complete this one, which is the thread that is waiting for longer time again now?
T1.
T1. So look at here. T1 has come back to the execution. So can I say by passing the fair, am I achieving the problem of synchronized keyword, whatever it is? Correct?
Yes.
So whenever you pass true, then whatever the kind of locking happening, that is called fair lock. Okay. Whenever you pass false or call no or constructor, called the no R constructor. That is called unfair lock. Okay. What is the difference between a fair lock and unfair lock? This is also most frequently asked question. So in the fair lock, what will happen? Whichever the thread that is waiting for longer time will be given the access first. Correct. Now in the unfair lock, there is no criteria. Any thread can execute anything once the lock is released. So the problem with the unfair lock is you can say that whichever the thread that is waiting for longer time will be in a waiting mode only. But if I am using a fair lock, will that be the situation?
No.
Okay. Now, for example, if you are booking a ticket or ticket booking system or that one, which one you prefer? Or
Fair
if you,
Wait,
yeah, fair
fair
lock,
lock.
because whenever you go for a internet like 10th class results or intermediate results or engineering results, there is a heavy load on the website. So at that time, which one do you prefer? Fair lock, correct? So whoever request is coming waiting for so long, they will be served, correct? Now, so that is about a whatever the drawback of synchronized keyword we achieved. Now, what is another drawback? I cannot achieve the lock in the month method and release the lock in another method. That I cannot do because synchronized block of code I cannot write. Across
Yes.
synchronized block, I cannot write across the methods. Now what I will do, I will display in this one, what I want to call display one, correct? Do you have a display one? No, let us create a display one method. Display one. Okay. Now, can I say I will call the display method inside this one? Okay.
Yes.
Okay, done. Now I'm acquiring, okay, let me pass the same object I'm passing. I'm acquiring the lock and then am I releasing the lock in the display method? No. In the display one method, I want to release the lock. Okay. Now that means, can I say now, if the code is executing, can I say I'm acquiring the lock in one method and releasing the lock in another method?
Yes.
Look at here. Yeah. Now let us
Yes.
debug this. Debug as Java application. So now let's look at. Can I say 4 thread started executing? Now, can you guys tell me which thread we will start wanted to process? Pick anyone.
Display one first completed.
No. Which thread we will do the debug? You tell me, I will do that. T1, T2, T3, T4, which one?
P3.
T1, let me do it.
Okay, T1. Okay, now. So can I say it is, so look at here. It has acquired the lock. Okay. And from display one, that means, can I say it is going into the display one method? Yes, but still it has acquired the lock, correct? Now let us look at display T0 is trying to access whether it will access or not. Is it able to access? It went into a stepping mode. That means whenever you are calling, after acquiring the lock, you are calling another method. Is it releasing the lock?
No.
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 Correct. Now T2, let's call. See, it went into a stepping mode. I mean, waiting. T3. So the main thread is not yet started. Let us start this thread. Yeah. So this also wait mode. Look at now so now let us complete this one. T1. Now, can I say I have acquired the lock in display method and I am trying to release the lock in different method?
Yes.
So now let us do. Whenever I release the lock, any of the thread, like whichever the thread that is waiting for longer time should come back to the execution.
Yes.
Yeah. See, now let us look at, some thread started executing T1, T0 because of the fair lock, correct? So this is sorry, Nagalakshmi, I'll be completing in another 5 minutes. Yeah. So the disadvantages of a synchronized keyword is, so whenever you are using a synchronized keyword, you cannot give a priority for the thread that is waiting for longer time. Okay. Now, but using the in the lock interface, we have a fair lock and unfair lock. By using a fair lock, whichever the thread that is waiting for longer time should be given the priority. Now, and the other one is we can acquire the lock in one method and release the lock in another method. So that kind of a flexibility is not present in a synchronized keyword. Whenever you're using a synchronized keyword or synchronized block, synchronized block you cannot write across the methods. Synchronized block should be written within the method. But my requirement is acquire the lock in one method and release the lock in another method. So which cannot be possible if you write a synchronized block across the methods, right? So that's why the lock will be better than synchronized keyword. Now, if you look at the latest Java implementations, they will be using a lock interface than the synchronized keyword. And this array list and vector, are these the classes created recently, or are these existing from so long?
So long.
So that's the reason you can see the synchronized keyword. Now, if you look at the concurrent hash map, okay, or any other thing, latest created, concurrent hash map is created latest, right? After, like compared to array list, it has come later point of time, right? If you look at a concurrent hash map or something, internally they will use a lock mechanism, not the synchronized keyword. So because of these advantages. Any questions?
So non-fail lock, why it will act as same as synchronized only, right?
Because yes, unfair lock is same act as a synchronized keyword. That means like so in the fair lock, what is the
advantage then? Like unfair.
See, the unfair lock, you do not have an advantage, it's a disadvantage.
Yes.
So that is, see here, that means if I'm giving you a fair lock only, but sometimes that means, can I say one whatever is happening in the synchronized keyword is not happening here, correct?
It's not happening.
Yeah, but see, whenever you're providing a flexibility, whatever is there existing, see, whenever you write a code, existing code should work and the new code also should work, correct?
Yeah.
Yes.
So what is the existing functionality? Synchronized, like synchronized keyword, what it is giving the flexibility, any thread can execute any point of time. You don't, because you do not have a control over a thread. So that is using an unfair lock, that is happening, which is whatever is existing. Using a fair lock, they are providing the drawback of a synchronized keyword, correct?
Yes.
Yes.
Yeah, that is a thing. Hope your question is resolved.
Yeah.
So
Instead of
nothing like that,
synchronized
but
block, we can go for unfair only, sir.
One person at a time. Yeah.
so it is giving a backward compatibility.
Yes. Yeah.
Right.
Yes. Yeah. The one who is asking can tell. There was a question from some other. What is that?
That this one synchronized. Instead of synchronized, we can use that unfair only, no? What was synchronized doing, that was done by unfair only.
Yes.
Okay.
But whenever you are using a lock interface, that unfair is also some problem, correct? Better to go for a lock fair mechanism. Yeah.
Yes.
But for example, if they remove this functionality, then whenever your JDK changes, then there is a problem, right? So generally, whenever there is any upgrade, it should provide you the compatibility with the old code, and then the new enhancements should be made. That is the reason. Okay. Now that is the main reason in the Lambda expression, or in the functional interface, whenever you are writing a default method, what is the advantage of default method in the interface? You can provide the backward compatibility, correct?
Yes.
That means in already all the existing classes will not give you any compilation error.
Yes.
If it is giving you the compilation error, all the applications which are working on Java should have been shut down for 1 month at least, right? Yeah. So any other questions, anyone? Does it understood today's class?
Yes, Karthik.
Yes.
Yes, Karthik.
So this is very important in terms of locking. So it is very hard to visualize it, but I will share this code. I request you, I have not written any big code, guys. One by one, like whatever we are doing, just think about it and write it. I will share the code, and I request you to please practice at home. And in the next class, we will look at read-write lock. What is a read-write lock? In the read-write lock, we have a read lock, write lock. Okay. So I'm not discussing any new topic, guys. Whoever wants to drop off, you can. Okay. I just wanted to give you the heads up what we are going to discuss in the next class. Whoever wants to drop off, they can drop off. Okay. Thank you. Now in the read lock, whenever you are trying to book a ticket, so whenever you go to the seats one, can I say, for example, you will select a theater and you will select number of tickets, and then it will show you the layout of the screen, right? Where are the seats are available? Am I right?
Yes.
So whenever you are on that screen, does it mean that you are booking?
No.
Whenever you select a seats, select some particular seats and click on next, then only I can say that you are selecting,
Booking.
correct? You are booking. Now, whatever the seats that you selected, whenever you click on the next button, okay, now let me draw it. This is very interesting, guys. Many of the interviews, this will be asked. Now, for example, these are the seats. Okay. Now, for example, Karthik has started executing. Same theater, for example, give me some, okay, IMAX. In the IMAX, I am trying to book screen 1. Okay. Now, let us take Ganesh is also trying to book IMAX screen 1. Okay. Now, let us take any other person wanted to volunteer? Say name?
Chiranjeevi.
Yeah. Okay. Chiranjeevi also wanted to book the IMAX and then screen 1. Okay. Now, let us take one more person, Bindu. So, Bindu also wanted to book screen 1 IMAX. Now, can you say all these 4 people are trying to book the same ticket? I mean, like same tickets in the same theater, correct? Okay. Now, can you say when all these people can come to this page, correct, at a time?
Yes.
Okay. So once you select it, so before this, you will select number of tickets, done. For example, what Karthik is doing, Karthik is trying to book these 2 blocked. Say Karthik selected these 2 tickets. Okay. Now I click on next. Now, whenever I click on next, can I say Karthik is trying to perform the right operation? Right? I wanted to right operation in the sense, I want to select these 2 tickets, right?
Yes.
Can others be able to see these 2 tickets?
Yes, they can see.
Can they block it?
No, they cannot block it, but they
can see the color will be changed, correct? That means whether my payment is completed or payment is done, that means can I say I am performing a right operation? Whenever I am performing a right operation, all other people can see this one, but can they access it? No, correct? So this is what when in read write lock, what happens is whenever the write lock is happening, all these are the read threads. Read threads will be in the waiting mode. Okay. But everyone can come to this page and then easily to select. Before I select, everyone can be able to, this will be clickable for all, right? Before I click it and then click on next, can these 2 seats will be clickable for all?
Yes.
Yeah. That means, can I say whenever they come to the screen, so all those will be called as a read threads. So read threads will be given to the access all. Whenever you are in a read mode, all the threads will be given the access. But if one thread, for example, Karthik is booking, that means Karthik is, that is a thread. When Karthik is trying to perform a write operation, that means Karthik is trying to acquire the write lock. Then can I say all other reading threads will go into a waiting mode. When I say waiting mode means they cannot select of this, correct? So in order to do this kind of a functionality, generally this read lock and write lock will be used. So which we are going to discuss in upcoming class. How does the read lock will happen and how does the write lock will happen?
Sir, one doubt, like if I'm waiting for Karthik is selecting the seats and remaining people, they are waiting more.
Yes.
So if the chances is there, Karthik he won't book the ticket and just
yes, that is what you can see. You can see if you come back after 10 minutes, if my payment is failed, can I say that these seats you can see the Ganesh can see the seats again?
Yes, sir, but the time remaining for principal waiting, right? They're
when I say
waiting time.
No, but see the problem, if you allow them, what happens? That seats will be booked by multiple people, and in the theater it will be like a fighting, correct?
Yes.
Yeah. So that is the reason whenever you go to any ticketing website, it's a RTC, train, anywhere. In the train you cannot select the tickets, but wherever you have a selection of like this, generally what happens is, like if this question is asked in the interview, there are multiple ways to answer it, but I suggest one way. It's up to you, whatever the answer you can give, but I'm suggesting this, that whenever one thread is writing, so whenever you click on next, on this, so write lock will happen. So whenever there is a write lock, so you will do from here in the write lock, you will call the payment gateway, correct? So in order to get a payment gateway, what is the time? 7 minutes or 6 minutes, correct?
Yes.
In the 6 minutes, you will get to know whether the payment is processed or not, correct?
Yes.
So whenever in the 6 minutes, if the payment is success, can I say that you will show directly in the dark color, correct? This is not available. For example, if the payment is failed, can I say, I mean, like you can release the lock after this payment confirmation, correct? If it is failed, then others can book it, correct? So this is how this can be implemented. So there are multiple ways to implement this scenario, but one way is by using this one. It's up to you whether you answer this or bet any other better solution. I'm telling you one solution since the topic has come. Okay, where this write lock and read lock can be used. Hope that answers.
Yes.
Yeah. So any other questions, guys? Anyone?
I have one doubt in the yesterday's session, sir. Can I ask that one?
Yeah. What is that?
So actually, sir, in scheduled feature class, like we have a method schedule and schedule at fixed rate, schedule with fixed delay.
Yes.
So my understanding is like schedule. If you use the schedule method, it will work only one time.
No. That is a mistake. See, whether it's a schedule or schedule at fixed rate or schedule at delay. So what a thread is doing, if you have schedule at fixed rate, schedule at delay, it does not mean that it will call the method again. No. For example, whatever may be the thread, what the thread is doing in this thread pool, there is a queue, correct? If there is a work in the queue, for example, you called schedule. Okay, what this thread will do, where it will take the work from the queue, correct? This is employee. Yeah. So can I say these are the objects, employee objects? On top of these objects, you have to execute your run method or call method, correct?
Yes.
Now, for example, whenever you say schedule 2, that means with a 2 minutes delay, it will take the work, correct? Yes or no? Now, after after 2 minutes, the thread will start taking the work from the queue. Now, after this is completed, again, every 2 minutes, like it will take 2 minutes, correct? Delay. Now, schedule at fixed rate or schedule at fixed with a delay. What happens is, schedule at delay means first you will take the work, correct? After that, you want to do for 10, now currently time is 7:30. Now, every day you want to do at 10 a.m. Okay. Then you have to calculate and then keep the day, time accordingly, and you call schedule at fixed delay. Okay. Then when the next work, if there is a work in the queue, if there is no work, it will not be repeat, correct? Because the because the threads will take the work from the queue. If schedule at fixed delay or fixed rate is given, and if there is a work in the queue, it will take the queue work accordingly, whatever the time slot you have mentioned. It is not like it is getting repeated multiple times. It will see whether it's a schedule or schedule at fixed rate or schedule with a delay. It will repeat until the queue is empty, correct?
Yes, sir. So actually, yesterday I tried like this. If I am, as our example, what we have done, we are taking the list of object. After that, we are iterating the object. So as I did the same way, it is calling after every, I'm putting 1 second or 30 seconds, like, sorry, that 1 minute, put a delay time, keep on executing the same object. Whether the data is not available in queue also, that is not,
No.
I don't.
So it's the queue, data will be available in the queue. If it is not available, then what happens? See, if the not, so here, till the queue becomes empty, the methods will be executed. It is not like continuously it will execute. If it is executing continuously, when it will break then, correct?
Yes, sir, it is not breaking. Keep on executing.
How many times it is executing?
Number of times, sir. I put a 1 minute, I am keep on checking. It is executing, keep on executing only.
So are you supplying any other data?
No, sir. Only that list of object only I am passing.
Okay. After completion, yeah.
And one more doubt, like we are calling schedule with the fixed delay or fixed rate. It is returning the schedule feature, right? After schedule feature object, we are adding L dot add, we are adding L dot add. If you're not adding L dot add method, add in the object, that is not repeating, and only one time that is also not properly calling.
Okay. Can you share your code?
Yeah, yes,
Yeah,
sir,
I will look at the code and I will let you know in upcoming class. Okay.
Okay, no,
Just share.
WhatsApp should I share or right here?
Yeah, so you can share it in the WhatsApp. Here
Okay,
after
sir.
if I close it, then it will be gone. So just share your code in the WhatsApp group. I will look at it and I will explain in upcoming class.
Okay, sir.
Okay. Yeah. So any other questions? Yeah. So if no question, that's all, guys. Yeah. So I will share the code. I request you to please practice over the weekend and then come back on Monday. Thank you, guys. Thanks for joining. Have a nice day.
Thank you, sir. Have a nice day.
Thank you.